better understand chemical engineering and its curriculum, let's take a close look at what makes this subject so fascinating. There are many aspects of chemical engineering. When people consider this field, most think of chemical plants, which is reasonable because many chemical engineers do work in chemical plants. However, you might be interested to know that this field is so much more.
Chemical engineers are able to understand the way the world works at a variety of scales. They can do engineering at the atomic scale, and they can translate it from that small scale up to the large scale of a production facility or a refinery, from the tiniest atomic scale to something the size of a city.
I think chemical engineering is unique because it is very interdisciplinary. Not only do we discover new chemicals, but we produce them in large quantities and bring them to the marketplace.
In general terms, chemical engineers transform raw materials to refined products. For example, crude oil is refined into gasoline. Natural gas is converted into ammonia fertilizer. Wood is made into paper. Potatoes become potato chips. And sand is transformed into computer chips. These transformations are quite remarkable.
The blend of innovative teaching, research, as well as networking with the energy industry and other industry gives the student an opportunity to get a high-quality degree as well as a very marketable degree.
At Texas A&M, the foundation of the chemical engineering curriculum is science. Obviously, chemical engineers must understand chemistry. However, like all engineers, they must also understand physics. Increasingly, biology is becoming fundamental to the practice of chemical engineering. The language of science is mathematics. Thus, chemical engineers must understand calculus and differential equations.
I teach thermodynamics, which many students find to be an intimidating subject, and what I love about teaching that subject is that I can distill it down into something students can understand. And I tell them it's like a philosophy course with math.
So, how does chemistry differ from chemical engineering? The main difference is scale. Chemists ride bicycles, and chemical engineers drive Mack trucks. Although chemical engineers are not chemists, they take more chemistry courses than other engineering students. The core curriculum includes thermodynamics, which describes where a process is going, courses in rate processes, fluids, heat transfer, mass transfer, and reaction kinetics describes how long it takes for a given process to occur. Courses in plant economics, process control, and process safety involve design and operational principles. Also important are liberal arts studies and electives, which allow students to further specialize in their fields of interest. The curriculum totals 128 hours and can be completed in 4 years if students are diligent. Chemical engineering is challenging. However, there are many rewards for the hard work.
With chemical engineering, if you like chemistry and you're willing to work hard, it gives you an understanding of the world that's both broad and deep, which I find to be the most rewarding part of it. So if that sounds like something you're interested in, maybe you should think about chemical engineering.
At the Artie McFerrin Department of Chemical Engineering, our students are offered an enriching and stimulating college experience. In addition to working with award-winning faculty and utilizing first-rate research facilities, our students are rewarded with foundational principles that will propel them into limitless career paths.
With chemical engineering, I actually want to change the world, believe it or not. I think it's a profession that has enormous impact, and using chemical engineering, I think I can make that impact.
Make your mark. Choose chemical engineering.